All right, this is the file. So I'm going to open another folder. Open. Add folder to workspace. So we're going to add WIG6F. And we're going to take this one, show your results prevailing quota premium. I will upload the files. Everybody knows how cars get bought in Singapore, how you buy a car in Singapore. So the first thing that you have to do is buy a certificate of entitlement, right? You don't buy the car, you buy a piece of paper that entitles you to buy a car. These certificates are in limited supply, right? They're in the range of about 2,000 a month, and people have to bid for it, right? So the price is the result of demand and supply, right? So the government provides a limited supply based on the road surface available in Singapore, right? And then people who want to buy a car can bid for that, and then they will win the bid or not, right? The result of that is that every month there is a certain value of the COE, right, that people have to pay for that car. And these values tend to fluctuate over time, right? And they tend to fluctuate in some sort of a predictable manner. And sometimes it's easier to buy cars than some other times. All right, so the interesting thing now is that one would be in the past, which would be the times, the months when it was the best time to buy a car. So what we have here is that, for instance, this is the time, which is year and month. So in the month of February in 2010, for category A, the price was $18,266, right? The categories are defined for based on the capacity of the engine, I think, right? And there's 3 capacities. I don't know exactly which are the limits. And I think this one is motorcycles, right? So motorcycles have the same thing. And what we want to discover is, when do we have local minima, right? So if we look at category A, right, we're going from 18,000 to 19,000 to 21,000, right? So you can see it increasing, 25,000, increasing very fast, right? And then it goes up, and then it goes down, and then at some point there's a local minimum, and then it goes up again, and then it goes down, right? So it takes a bit of time. All right, and we have data till May of 2019. So how do we go about doing this? Let's start like yesterday. Let's start with a new Python file. So we're going to say best time to buy cars.py. We're going to go here and we're going to perform exactly the same operations, right? So this part is exactly the same, except for the file name. So as I come here, actually I have to go, the best thing to do is come here and say copy relative copy path, and in here I am going to replace this by the name and the file name, and the file name doesn't need the entire path because it's in the same folder, so we're going to keep it short. This group of interest is no longer useful. All right, so we delete it. All right, so let's see what data have we gotten. So I'm going to say for record in records, print record. This will show us the records, and we're going to go to the command line, Python 3, best time to buy cars, and you can see the data. All right, now we're going to do this in simultaneously for all the categories, right? So we're going to separate categories, the categories. So records, we're going to call it A. Category A is going to be record in records, record for R in records, if R, and then if we look here, the second element, the second column is the category, right? So if R 1 equals category A. Yeah, so now if I do records A, obviously this is filtered, right? So you see we only have category A here. Now whenever we have a column with the same value everywhere, that column is not really needed. So what should we do? Well, remember this R can be replaced by I put a set of brackets, and it's R0, R1, R2. So this is exactly the same thing, right? But here we single out this column, which contains the same value now, right? So if I delete this column, I will be left with only the first two columns. Yeah. All right. Now, instead of copying this, so if I copy this and say category B, category C, category D, I'm going to get those numbers. But it's nicer to write a procedure and say def filter category, and we're going to say C, category C, and we're going to return, and I'm going to take a copy of this. Actually not a copy, I'm going to remove it, put it here, and then instead of having an A here, I'm going to have a C. Yes? So then records A is filter category A. Records B is filter category B. Records C. Okay, actually I don't want to keep typing. I'm just going to cut and paste, or copy and paste. So this is C, this is D, and similarly here we have C, here we have D. And let's check that everything still works. I mistyped here. Right, everything works fine. if I go here and want to do records D, right? We know that records D are smaller amounts because they're for motorbikes. We can see here that they are smaller. All right. So the next thing that we want to do is sense the local minimum, right? So the local minimum is such that the current element is less than the previous and greater than the is smaller than the previous, smaller than the next one, right? Those are the local minima. And then also, are those the best times, right? We might want to have a certain distance from the average. Maybe, we want to make sure that it's an absolute minimum, right? But we're going to look at how the price fluctuates. Generally, the COE prices have increased over the years on average, right? But they still fluctuate very clearly. So let's detect the local minimum, right? So having a series, right? This is essentially a time series, what we call a time series. So we have a point in time and a value for that time, right? Let's say local def minimum of time series TS, right? And we're going to need to accumulate them, right? So the result is going to be initially an empty list, and then we're going to say for I in range, we're going to start at 1, not at 0, right? Because we want the first element that we check, right, has to have a left and a right. So the first element that has both a left and a right is the one at index 1. It has 0 on the left and 2 on the right. If I start at 0, there's no element on the left. There's no previous element. And I want to end at len ts minus 1, right? Remember that, so the last element in ts is at index len ts minus 1, right? But this range goes from 1 to len ts minus 2 because it's exclusive on the right. So when I am on len ts minus 2, I will have a previous element as well as a next element. The len ts minus 1 is the next element, right? So I have to be very careful because I don't want to try to access array elements that do not exist. Yeah. And what we're going to do is if ts, right? So I'm going to have I minus 1, and the value that we're looking for is at index 1, right? So this is the second column. If we look here, if we look here, this is the second column. This is where the price is. Yeah. And then I want to compare this price with both the left and the right. So for instance, if you look carefully, this is a local minimum, right? It's smaller than the previous, smaller than the next. All right, and it's in the second column, which is at rank 1, at index 1. So this is why I have this one here, because I want the second column. So this is the previous element. This has to be greater than ts I and 1. Also the second column, which has to be less than ts I plus 1 and 1. So if this happens, and notice that Python has this very cute notation, which is very handy, right? So most languages don't have this, right? So I can say 2 greater than 1 less than 3, and this is true, right? 2 greater than 1 less than 0, this is false, yeah, and 0 less than greater than 1 less than 3 is also false, and so on. Let's get out of here so I can have chained comparison. So if this holds, then I can add TSI. And then I can return R at the end. All right, so we're going to say for R in local minima of records actually there shouldn't be too many, so let's just print them directly. Print local minima of records A. Okay, let's start with this one. Right, so these are the best times to buy cars for category A, right? So November 2010, right? And then and how is this? Oh, so sorry, April 2011, November 2011, March 2012. So can you see the pattern already? July 2013, right? February 2014. So it seems like, you know, one time around the beginning of the year, one time around the end of the year, right? But even so, the prices are slowly increasing. All these minima are have been increasing actually. Wait. So they had a peak here, and then they started to decrease a little bit. All right. With a last time when it was good to buy cars was March last year, right? And we stopped there because we don't have enough data beyond mid of 2019. So let's try to be a little bit more organized in printing. So I'm going to say print category A, and then I'm going to print everything a little bit indented for record in local minima of records A. Print, and I'm going to indent a little bit. Okay, so now, right, we have all the time. So you see about twice a year, right? Some are a bit fake, right? So these are just because of fluctuations during those years, right? And we should try to eliminate these. All right, so one interesting thing is, how would we eliminate these? Right, they're very close to each other. The actual minimum is here. And all the 4 that we have here, these ones maybe, right, should only, right, these 2 and this one probably should not appear, because they're not so much of a minimum, right? They're just out because of certain fluctuations, right? So how would we do that, right? One way would be to request that instead of just being greater than, all right, we can request that this difference be a bit greater than a certain value. Yeah, so let's say greater than 100. So we could say if TSI minus 1 greater than TSI 1 plus 100, and I will have to put a backslash here. So I'm going to take this guy here. Right, so we have a tolerance of 100, right? So I'm going to call this guy T equals 100, and instead of putting 100 here, I'm going to say T. So if at any point I want to change this value, I don't have to change it in 2 places. Okay, I'm going to say T, and let's see what we get now. Oh, another thing is that actually these are not numbers, so let's turn them into numbers. So I'm going to actually say float, I think. So I want to turn them into real numbers. Okay, so now we have a lot fewer real minima, right? So I see that the very good times to buy cars were a lot fewer for all categories. The question is why? Oh, I said records D everywhere. Sorry. This is records A. Records B.
What is float and not integer?
Well, normally currencies are potentially real numbers, not integers, right? So it so happens that this data set doesn't record the cents, yeah? But in general, you could have a price that has cents. Okay. Yeah, so it's strange. So for cars we still have, right? But because they're so large, these are so large that $100 is not much, right? Whereas for motorbikes 100 is a lot because numbers are a lot smaller, right? So instead of using an additive number, let's use a multiplicative number, right? So I'm going to say start T, and then start T, and then I'm going to make this T equal to 1.05, let's say. Let's see how this works. And then we have a lot fewer of these. Maybe 1.05 is too large. So let's say 1.02. Let's see how this works. Okay. So a lot fewer. Let's say 1.01. So even more. Okay. So that's an interesting result. All right. Another thing that would be interesting to do is draw the evolution of the prices in time. All right. So you can try to do that as well. All right. In order to do that, we're going to take advantage of the Pygame package that we have learned. So I'm going to go into adding a folder. I'm going to go back to week 5F, I think. And we're going to take all this stuff and put it here. We're going to import all this stuff. All right. Remember that you might not have this font. And then, as before, we're going to take the skeleton, which gives us the ability to quit. And sorry. And we need to, oops, keep going to the other window. Right, so here in between, I'm going to put the marker again. We're going to draw our graph. Yeah. So the first thing we're going to draw is our system of coordinates. Yeah, we have a window of 800 by 600. So we're going to leave a width of about, say, 2% of the width and height, right? So we have to draw some lines. So the drawing part is pygame.draw.line, I think. And for the line, we go from, let's say 0.2%, right? So so we need coordinates 0.2 of, first would be width, and 0.02. Times height. Right, this is the one end. The other end should be at 0.02 times width and 0.98 times height. All right, so for a line, we need, I think, a color and a thickness. So we need a color, which is, let's say we use yellow, which would be 255, 255. No, it's 0.255, 255, right? And then thickness of 3. So let's see how this works. Line 76. So I want by game draw line. Oh, I need a screen. Again. So screen color. So the color is the first. So let's put the color first. All right, so we have, well, it came out blue. Okay, we're going to leave it to blue. So this would be the vertical coordinate line, right? And let's draw the horizontal coordinate line. Oops. Let's close this. So I'm going to draw a line on the same screen, same color, and I'm going to start from 0.02 width and 98 height, and I'm going to go to 0.98 times width and 0.98 times height. Okay. Sorry, back here, escape, back here, run again, and yeah, comma would be good here. Yeah, everybody's following. And so now we have two coordinates. All right, so in these coordinates, we have to place all our data. So how do we do that? So we're going to do draw data, and we're going to say which data set, C, right? So we're going to have a draw data A, a draw data B. Let's do draw data A first, right? And we're going to define what it means to draw the data. All right, and then there's going to be a data set here, right? Category. and then I'm going to have local minima of filter category. So my data set is local minima filter category of C. Yeah. So now I have a data set. Now the length of the data set has to decide how many points, how many divisions I have on a horizontal axis, right? Yes? So and then I need to know, because of that, the length of a division. So the length L of a division is going to be, right, if I should have left it on. All right, this will still work. Right, so the length of this from here to here is 0.94 of the width, right? Because this space, I wish I had on a, maybe it's more visible here, right? So you can see that there's a space here. This space is exactly 0.2%, right? 2%. And this space between the end of the line and the edge of the window is also 0.2, right? 2%, right? And the same here and here, right? So the length of the entire line is 94%. So I'm going to take this 94% and divide it by the length of the data set that I have. Right? So I want to know how many pixels per month. Yeah, does it make sense? So I'm going to call this L. The length of a segment is going to be 0.94 divided by, or times length times width, right, divided by len of ds minus 1 right? Why? Because I'm not counting the numbers, I'm counting the intervals in between the numbers. Yeah. Well, actually, I can count the first interval as the leading interval as 1, so I can go from here, right? I can do len ds. The other thing is that I don't want to go with the last point exactly at the edge of the graph, so maybe I will say 0.9 here. I'm going to give it some leeway. So now I'm going to start drawing, right? So I have len ds minus 1 intervals, right? So for interval equals range, in range from 0 to len ds minus 1. Well, actually, let's put it from 1 because that's good enough. No, let's go from 0, sorry. Len ds minus 1. Right, and now I have to draw the segment. Okay, so another interesting thing is, what should be the height? Okay, and then I do not want to draw the to go from 0 to maximum, right? Because my data is actually in a relatively narrow interval, right? Starts somewhere at 30,000, let's say for category A, starts at 30,000 and goes up to about 70,000, right? So if I start from 0, right? If I start my interval from 0, I'm going to waste a lot of space at the bottom, right? I want my graph to be as large as possible, so it's visible what's going on there. All right. So Another thing is I want to get the minimum and the maximum. So we're going to filter the prices only. I'm going to say prices equals, and I'm going to have the prices are in the second column, right? So R1, the second column for R in DS. Yes, and then I'm gonna say price min equals min prices, P max equals max prices. That's another very useful thing that Python has. And then I'm going to make P min correspond to maybe 0.1 of my height, and P max correspond to maybe 0.9 of my height. Yes? All right. So I'm going to need a coefficient. So if I have my price, where do I put it vertically? Right? If I have my price P, let's say that I have a P that is my price, right? So my P is going to be placed at, right, P minus P min, right, divided by P max minus P min, right? So now it's a proportion, it's a percentage of the interval, right? And now I have to fit it in the window, right? In the 0.1 to 0.9 in the window, right? So the 0.1 to 0.9 means an interval of 0.8, right? So I'm going to multiply it by 0.8, yeah? And I'm going to add 0.1 as an offset. So I'm going to say def price chord P, return this. And let's do it the way we learned, put it on the next line, right? I can put this def anywhere I like, but in general, it's better to put it at the top. So for I in range from 0 to len ds minus 1, all right, I have to draw a line between the current element and the next element, right? So I have to draw a line by game draw dot line screen, and we're gonna do this again. And then what's the beginning, right? The beginning is the current I, right, at I0. So I'm gonna have I am going to have for the x, I'm going to have I times L, I plus 1 times L. So I plus 1 times L. And then for the y-axis, I'm going to have price chord of, and actually I'm wrong because I can't put this anywhere I want. I have to put it right here because it has to be, this has to be defined. P min, P max, they have to be defined before I use them here. Okay. And then another thing that I have to do here is say non-local pmin pmax. Right. So if I'm accessing variables from outside of the procedure, I have to say that they're non-local. So I have price chord of ds I and 1. Right, so this is the start coordinate. The end coordinate is going to be I turns into I plus 1. So this becomes I plus 2. And this becomes I plus 1. And then before the coordinates, I need a color. So let's take a color green, maybe 0, 0, 2, 5, 5. And then we're going to have a width of maybe 2. So let's see if this works at all. So I made I plus 1. Line 81. Commas are good. Oh, and again, we have forgotten to turn them into numbers. So let's do that. Right. We should do that early on. We should have done that early on. Actually, we should do it here, right? So this R2 should be float. And we're not seeing anything being drawn. That's a shame. All right, let's see. Let's print what we're drawing so as to make sure that we're drawing the right things. So one very simple thing to always make sure that we're drawing the right thing is take this entire line, print it here, right? So when even though I copied it as a function application, once it's like this, it looks like a tuple. Yeah. So again, Python is very useful. The screen is not something printable, so I'm not going to keep it. So now let me see what gets printed. All right, so these are very, very small. These are very, very small. So let's see what's going on there. Oh, this entire thing. Draw the price chord. This entire thing has to be multiplied with the height. Okay. Okay, so these are the prices. We still don't have enough prices. We have too few prices. They should be a lot more. All right, but at this point, at least we know that we have some lines, so I don't need the printing anymore. So another thing is, I actually don't want the local minima. Sorry. I want the entire data set. So we're just filtering the category. So this is the evolution of the price. Again, it should be a little bit further to the right. All right. But this is the evolution of the price. Is this fine? Yeah. Everybody's following? Again? Yes. All right, so this L, let's start again. So it's 0.9 times width divided by len ds. So I can say 2 here and 3 here to make it further to the right. Okay, a bit better. All right, so this is actually not a good solution. So I don't want to use I plus 1. Let's just use I, right? And I plus 1. But we use an offset, right? So we're going to have an indent equals this indent I have to give it as a fraction of the width, right? 0.05 maybe times width. So I'm going to write here indent plus and another indent plus, right? So this moves everything a little bit to the right. Okay, now it looks good. Yeah. So now another thing that we could do is put some values on the vertical and on the vertical axis and the horizontal axis. All right. So before we do that, let's add all the graphs. All right, and also we can see how correlated are they at that point. So one thing that we need in draw data, apart from the data set, is the color. All right, so I'm going to say color here. All right, and when we draw data, let's go back and pick colors, color picker. Right, so this is Google's, and let's do an orange. So we have these. We can draw all of them like B, C, D, and then let's pick different colors. Let's pick a green. Yeah, maybe something like this. Then let's pick a bluish. Let's pick a what? Purple. All right, so let's see what we get now. So interestingly enough, this one is the last one, which is the D, which is the motorbikes, is not very correlated with the others. But you can see that all the other ones are relatively correlated. Yeah, which makes sense. All right. Another thing would be interesting now to put the years, like maybe every 5 years, right? Maybe for every 5 years we put a little bullet on the horizontal axis and we put the year there. Yeah, at the beginning of the year. So for January of that year, like 2010, we go to 15, 20. Oh, how much data? Because it goes up to 19, maybe every 3 years. And actually, we should actually have a variable. We should be able to pick the interval. All right. So data should be we starting at 2010. We go up to 2019. Yeah. Whoops. Oh, come on. Four, 5. So we're going from 2010. We should be able to say every 2 years, maybe. Yeah. So we're starting at 2010, 02. So let's draw the ticks first, right? So we're going to have a small function here, which we call def tick, and we're going to have a number that represents the fraction of the width where it has to go, right? So it's a fraction, and then it's a fraction. It's a it's an x, right? And then we're going to have a little line. So whenever we draw a line, we draw something like this. And then we should draw it in the same color as, what color were we using? For the 2 axes, we're using this some sort of blue, right? And all right, so it's being drawn. So this is the X. The X stays the same, and we're going to have an X here and an X here, right? It's a little vertical tick. And then here we're going to have from 0.98 times height, which is exactly what the line is, to 0.97 times height. All right, so just a very little tick with a width of 3. All right, and then we want to do these ticks for every 2 years, right? So we're gonna do it every 24th time. Right, so as we draw the data, let's also draw the ticks. Right, so we're going for I in range, I 0 to len ds minus 1, and I'm going to say if I percent 24 equals 0, tick off, and then the X has to be this guy. All right, let's see how this works. Yeah, so we see the ticks. Right? Now the next thing that we like to do is put the years. All right? So the year that corresponds to this is the first 4 characters of the first column. Yeah, of what we find in the first column. So how do we do that? I will have to search. I'm going to say Pygame. Draw text. So we have to do these 2 steps. Step 1. Sorry, here. And then inside the tick, we're going to perform this operation as well. So text surface, my font. My font is, do I have a my font? And this is let's call it like this. And then we should go back into the Pygame tutorial and all right. So we have a my font. Do we have a my font? Oh yes, we have a my font. Okay, wonderful. So my font render, and then we do the blit part. which needs to happen here. All right. Now, this text will be this text that we put here. So we're going to say text, right? And then this sum text is going to be the text. And then we're going to pick a color. Let's go and pick a color. Might be a nice color. Something like here. This one, or no, maybe something along this line. All right. So we have to give some coordinates. So we're going to put the text just above the x, right? But it has to be centered a little bit. So we're going to say x minus maybe, I don't know, 20 pixels. All right. Do I want to put it above or below? Let's try above first. So I'm going to put it at 0.94 times height. Yeah, so the tick is here from 0.98 to 0.97, and then I go further up to 0.94, and that's where I put the text. And let's see with this tick, right? What we want here is DSI, and we're taking the first 4 characters, right? So we're taking the characters from 0 to 4. Oops. Text must be a Unicode or bytes. And how come it's not? $9.93 in tick. So this text is not sorry. So DSI is the record. DSI 0 is the first column, and from here we select 0 to 4. All right, is this clear? So DSI is the row which has year plus month and price. So the first column is year plus month, and out of that first column I select the first 4 characters, which is just the year. And we want them smaller. So we're on the right direction. Where do we get the size of the font from? From my font. So we're going to take a very small font, maybe like 8. An 8-point font. All right, this is too small. A little bit bigger. So let's say 20. Okay, something like this. We can still rearrange it a little bit to be more centered, a little bit higher probably would be good. All right, but we have years. Yeah. And the last thing that we want to put is some values on the vertical axis, just that the vertical axis actually doesn't have the same scale for each of the for each of the graphs. So we're going to leave that as an exercise. All right. So we should make the scales uniform, and we should compute a global price minimum, price maximum. Right. That price minimum, price maximum would be contributing to the scale, and then in between price minimum and price maximum, we can put a tick for every, say, I don't know, $1,000 maybe, or maybe $5,000. Okay, so this is graphing, right? Just another way to have fun. Cool. Questions? So this is it. Tonight I will upload the remaining two